Yes, hello. Hello, Bhanu Prakash. Good evening. Yes, so the voice is clear. So today we are going to discuss about the random variable and random process. And before starting the session, let me introduce myself. So this is Saket Verma, and I have done MTech from IIT Guwahati, and I'm having more than 13-year experience in the field of GATE and ESE. Yes, yes, good evening, Mukesh. Good evening, Bhanu. And this is my Telegram group where you can get the different PDFs of your, if you are looking for the notes of any subject, then you can contact me in this particular Telegram group where I can give you the different PDF available with me for any subject. So, and one more thing that from the 23rd of August, we are bringing a session for all of you, right? We are bringing a session for all of you in which we are going to discuss about the IC Bangalore previous year question papers. So as you can see that here 2002, 2008 and 2016 paper will be discussed. So to follow this, you can subscribe to the channel. This is starting from the 23rd of August. Okay, it is starting from the 23rd of August. And if you are looking for a scholarship to get the complete course of GATE 2024, then you can give this scholarship test and you can avail up to the 90% discount on the full course for the GATE 24, GATE 25, etc. And this will be on the 20th of August, that is on Sunday, 9 a.m. to 9 p.m. The portal will be open and you can register yourself for the scholarship test and appear on that. And according to your merit, you will get the scholarship and you can avail up to 90%. So today we are going to discuss about the random variable. So what is the random variable? So first of all, let's understand that what is and how do you define the random variable. Okay. So the random variable is defined as it is nothing but a mapping of, you can simply, in simple words, you can say mapping of sample space to the real axis. Okay, it is nothing but a mapping of sample space to a real axis. If you do this, then definitely you are performing, you are assigning a real number. Okay, like you can also say in this way. Okay, suppose we have a sample space S. Okay, suppose we have a sample space S, and by some rule and by some rule or function, okay, by some rule or function, if we assign a real number, a real number to each sample point in the sample space, we create random variable. Okay, we create the random variable. This is how you can define the random variable. Okay, so the random variable can be seen as a mapping of the sample elements, that is the sample space element, to the real axis. or it can also be called as the mapping of simply sample space to the real axis. How you can draw it? Okay, so suppose these are the two different values, lambda 1, lambda 2, and you if you assign some real number, suppose 1 and 2 to the these sample elements. Okay, this is the real axis. Okay, hello Manasvi, good evening. So we have the two elements, lambda 1 and lambda 2 in the sample space, and in this two elements, to these two elements, we are assigning a real number, then it is called a random variable. So here we will call random variable. So the random variable will be x, which is a two different values, which is containing two different values, 1 comma. Okay, and one more thing, that suppose you can say that we are performing another example you can take. Yes, Harsh, if you are learning it for the first time, then solve the previous year question as much as possible. At least 2 to 3 times you solve all the previous year questions. You will get an idea how to approach to any particular question. So, for example, if you say we are performing an experiment, suppose we are tossing a coin twice, tossing a coin twice, and random variable is equal to the number of head appears. Then how can you define? Okay, so if I give you one example, let's suppose we are tossing a coin twice and the random variable is defined by the number of heads appears on the toy. So what will you say? How will you calculate the value of random variable? How will you calculate the value of random variable in this case? Suppose this is an example, then how will you say that what are the different real numbers you get? बताओ कौन सा रियल नंबर आएगा? कैन यू टेल मी द नंबर, रियल नंबर? कैन यू टेल मी द रियल नंबर? ठीक है, आप ये भी बता सकते हो कि व्हाट आर द सैंपल पॉइंट्स यू विल गेट हियर by assigning one event as random variable? No. According to this example which I have written over here, think once that how you will assign the real number and what are the different real number. Think once. Number of heads as the random variable. How many number of heads? Yes, like Sri is saying, x equal to 2 you are getting. So suppose this is your real axis. Okay, suppose this is the real axis. When you perform a experiment, a random experiment, what will be the sample space in this case? The sample space, you are tossing a coin twice. So the sample space will be head, head. Okay, or let's write in this way. Tail, tail, then tail, head, then head, tail, and then head and head. You may get these values, right? So how many sample points are there? 4 sample points are there. So you can write the 4 different sample point over here. So these are the four different sample points. Let us say S1, S2, S3 and S4. So number of head in this first element, number of head in this is 0. The number of head is 0. So the sample point 1 will be assigned to 0. The number of head in these two is 1. Number of head is 1. So you will assign a real number 1 to this particular samples element S2 and S3. And here the number of head are 2. So it is 2. So this is how you define the random variable. So what is the value of random variable? The value of random variable will be 0, 1 and 2. 0, 1 and 2 will be the value of random variable. Got it? Okay. Now let's define one more random variable. Suppose we are performing, okay, suppose we are performing a random experiment. Okay, a random experiment in which a coin is tossed and a dice is thrown. Okay, suppose we are performing an experiment, a coin is tossed and dice is thrown simultaneously. Number of assigning the real numbers, assign the real numbers as the number on the dice, the number on dice, assign positive real number. Okay, positive real number, assign the positive real number, assign the positive real number as the number of dice, as the number on dice appears, and negative real number as, and twice of negative real number. Okay, so listen carefully, and twice of negative number and negative real number, twice of the, and negative real number twice of number appears on the dice. Can you tell me what will be the number? Can you tell me what will be the number? How, what will be the sample space and how many elements will be in the sample space? Can you tell me? how many elements in the sample space? How many elements in the sample space? Can you tell me? Yes, so that is the very actually good one, good example where it is easy to understand that how much you have understood. Sir, which means, for example, -2 is one of the sample space. No, let me tell you. I am drawing the sample space. Okay, I am drawing the sample space here. So the sample space will be head and 6, head and 5, and head and 4, and head and 3, head and 2, and head and 1. Similarly, we get tail and 6, tail and 5, tail and 6, 4, and tail and 3, tail and 2, tail and 1. Okay, these are the different elements that we will get. And assign the positive real number as the number appears on the dice with tail, and negative real number of appeared dice with head. Okay, this is like this. So we have to define here 1, 2, 3, 4, 5, and 6. So it is the mapping. And here -2, -4, -6, -8, -10, -12, like this. Okay. So in this way you have to define. Understood now? So in this way you can easily write the random variable. Okay, you can easily write the random variable according to this. Okay. Now to analyze the random variable, we have the two important function. Okay. So to analyze the random variable, we have the two important function. One is known as cumulative distribution function. Cumulative distribution function. How do you define the cumulative distribution function? From the mathematics, you might be knowing that it is nothing but the f of the cumulative distribution function of a random variable x is equal to probability that random variable x takes value less than equal to small x. Okay, so suppose we perform an experiment. Okay, suppose we take the example. Suppose, for example, tossing a coin twice, or simultaneously we are tossing a two coin. You can say any one of this. Tossing a coin twice will give us the sample space head, 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 tail, tail, head, and tail, tail. Okay, and the probability of this, we are assuming that the random variable x is having the probability, it is 1 upon 4, 1 upon 4, 1 upon 4, and 1 upon 4. We are assuming that, okay, the random variable is having the values, the random variable is having the values for any rule, means we don't know the rule, just I am randomly taken. Okay, I am randomly taking that the random variable is having the value 1 to 4. Okay, now you tell how will you calculate. Okay, if I ask you to calculate the PDF, sorry, CDF at x equal to 0. What is the CDF at x equal to 1 in fact? What is the CDF at x equal to 1? According to the previous discussion, at x equal to 1, we have the probability 1 by 4. So how will you write? The probability that random variable x takes value less than equal to 1, which is equal to probability of x equal to 1. So it is nothing but a 1 upon 4. Similarly, fx of x equal to 2, that means the probability that x is less than 2. Okay, x is less than 2. So the probability of x equal to 1 plus probability of x equal to 2. So how much it would be? 1 upon 4 plus 1 upon 4, it is equal to 1 by 2. Okay, it is equal to 1 by 2. Now, fx of x equal to 3. So, x equal to 3 means probability that x equal to less than equal to 3. Less than equal to 3. And in this case, we will get probability that x equal to 1 plus probability that x equal to 2 plus probability that x equal to 3. So how much we will get? 1 by 4 plus 1 by 4 plus 1 by 4 is equal to 3 by 4. And fx of x equal to 4. So probability that x less than equal to 4 is probability that x equal to 1 plus probability that x equal to 2 and probability that x equal to 3 plus probability that x equal to 4, and when you add all of them you will get 1. Okay, so when you will draw it, okay, when you will draw it, you will get the PDF, not the PDF, the CDF is like this. At x equal to 1 you got 1 by 4. At x equal to 1 you got 1 by 4. Then at x equal to 2 you got 1 by 2. Then you get x equal to 3, 3 by 4, and then x equal to 4. You received the total value of 1, and after that it continues to 1. This is the values 1, 2, 3, 4. This is x and this is fx of x. So it is 1 by 4, it is 2 by 4, it is 3 by 4, and it is 1. Is it clear? Is this diagram clear? How we have got this? So it is the example of staircase form of CDF. Staircase CDF we are getting, and an example of a discrete random. An example of a discrete random. Okay, why we are calling a discrete random variable? When the random variable is, or the CDF is having the finite number of discontinuity. Okay, when the CDF is having the finite number of discontinuity. Okay, when the CDF is having a staircase form, or you can say the finite number of discontinuity, then we call it as then it is a discrete random variable. Okay, then it is a discrete random variable. Okay, so we will call it as a discrete random variable if it is having the finite number of discontinuity. So here you can see that we have one discontinuity over here, one discontinuity over here, and total number of 4 number of discontinuity. So example of discrete random. Distinct value we should have in the random variable. Now, what are the different properties? So, can you comment in the comment section what are the different properties you know about the CDF? Properties of the CDF. Properties of the CDF. Properties of the CDF. Any property which you know? Can you comment? Any property? The first property is this is the CDF. I am not talking about the CDF. I am talking about the PDF. The property of the PDF is yes. So that is the first property. You can say the Vikram is right. The first property according to the Vikram says that you can say that the at infinity, not exactly the maximum value also you can say, but at infinity we get the value 1. Or what you said according to that if I write, then it is the fx of x is less than equal to 1 and greater than equal to 0. Okay, can you tell me what is the value of CDF at minus infinity? Can you tell me what is the value of CDF at minus infinity? What is the value of CDF at minus infinity? Yes, so it is 0. It is 0. Fourth, one more property we can say, what is the probability that random variable x takes value greater than equal to greater than x1 and less than equal to x2? What is the value of fourth? What is the value of fourth property? what is the value of fourth property? Yes. So that's also correct. Fx of x2 minus fx of x1. Now, can you tell me what is the value of probability at x equal to x? Now, write the fifth property, Vikram. Yes. So no, actually, Vikram, it is not like this. It is fx of x minus fx of x minus. Okay, you are saying fx and fx minus infinity. No, fx minus and fx of x minus. Okay. Now, can you tell me what is the value of this fx in terms of unit step? If I want to write in terms of unit step, can I write? If I want to write in terms of unit step, then can I write it? So in terms of unit step, it can be written as fx of x is equal to 1 upon 4 is the height and u of x minus 1 plus 1 upon 4 u of x minus 2 plus 1 upon 4 u of x minus 3 and plus 1 upon 4 u of x minus 4. Okay, so in terms of unit step, so that means whenever there is a discrete random variable, you can write, whenever there is a discrete random variable, you can write the CDF in this form. I equal to 1 to n, the probability of xi and u of x minus xi. This way you can write the CDF if it is having the staircase form. If it is having staircase form. If it is having the staircase form. Okay, if it is having the staircase form, then you can write the CDF in terms of unit step function. Yes, so there is one more property. The sixth property is the sixth property. If x2 is greater than x1, if x2 is greater than x1, then the CDF at x2 will be greater than or equal to fx, that the CDF is non-decreasing, right? The CDF is non-decreasing function of x. CDF is non-decreasing, correct? So greater than equal to also will come, okay, Vikram? So don't forget this equal sign, greater than or equal to, because it can be equal also. Here also you can see if you choose the two different values of x. Suppose you choose the two values like 2.5 and 2.7. So the 2.5 and 2.7. So 2.7 is greater than 2.5, but the value of CDF is equal, that is 2 by 4. The value of CDF is equal, that is 2 by 4. Okay? The value of CDF is equal, which is 2 by 4. Now let's define the probability density function. How will you define the probability density function? Yes, definitely I can take, but that problem right now I don't have. Okay, so we have the PDF which is fx of x. It is nothing but the differentiation of CDF which is fx of x. That was the previous year question, Vikram, I guess. Yes. Integration of PDF is CDF. Yes, now you can define it in this way. Now, what are the different properties? And for discrete random variable also, for discrete random variable. Yes, Vikram, I am taking that question. Okay. Just wait a minute. For random variable, for discrete random variable, this fx of x is given by summation I is equal to 1 to n, then the probability of xi and delta x minus xi. And for the previous example, if I differentiate it, so what we will get, the differentiation of unit step? Differentiation of unit step you get impulse. 1, 2, 3, 4. All will be having the height 1 upon 4. This is for the previous example, which we have taken for the understanding of the CDF. Yes. Now, what is the properties? What are the different properties? Properties of PDF. Okay, you got the idea for the question? You were asking that a PDF was given and it is asking for the CDF, na? So you got the idea, means you are saying that you are going to differentiate from the option. The first property is fx is greater than equal to 0. The second is the total area under the curve. Yes. So total area under the PDF. The total area under the PDF is always 1. And the third one is when we want to calculate the probability for the given range x1 to x2, then we write like this. Similarly, here we can also write integration from x1 to x2. We can integrate the PDF. The fourth property, we can calculate the CDF, that is fx of x, by integrating from minus infinity to x, fx of epsilon d epsilon. Just change of the variable I'm using. Yes. So this is the final answer. Properties. So Vikram, I will take your question now. Quickly, I will tell. I think you were talking about this question. This was the PDF given, right? And you want to draw the CDF. Okay. So you can calculate in this way. See, this P of x is y is equal to mx plus c. The slope is positive. The slope is 1. So can I write x plus 1 for x between minus 1 to 0? Okay, and then minus x plus 1 for x 0. We have to integrate from minus infinity to x. Okay, now case number 1 you can take. Case number 1, if the x is less than minus 1. Okay, if x is less than minus 1, let us suppose x is minus 1.5. Okay, now according to the property, fourth property of the CDF which we have written, we will write in this way. Okay, how will you write? You will write in this form. The PDF, which is Px, which is x plus 1 for the given range, what you will write, fx of x is minus infinite to x, minus infinite to x, this p of x dx. This is the definition, p of x. Instead of x, you can write the epsilon also. Now, when the x is less than minus 1, when the x is less than minus 1, can you tell me what is the value of PDF? Can you tell me what is the value of PDF if x is less than minus 1? If x is less than minus 1, can you tell me what is the value of PDF? Yes, it is 0. Okay, so that's why I have taken one example like minus 1.5. So if I take minus 1.5, it will lie somewhere here, minus 1.5. So in this range, minus infinity to minus 1.5, the PDF is 0. So it is 0, hence the overall integration will be 0. So there will be no graph before minus 1. There will be no graph before minus 1. Okay, understood? So it is sure that the graph will start from minus 1. It is sure that the graph will start from minus 1. Now case number 2. If you take the value of x, between any value between -1 to 0. Okay, any value -1 to 0. Suppose the x is lying somewhere here. -1 to 0, you can take -1 by 2 also. So now you think of the same way, the fx of x integration from minus infinity to -1 by 2. Okay, instead of taking the -1 by 2, let's write x only. But remember that this x is in between the -1 to 0. You can take -1 by 2 for example. Okay, so what will be the value of PDF in this range? So the PDF you will write minus infinity to -1. It is having the 0 value, and then from -1 to x, it has the value x plus 1. So you will write epsilon plus 1, d epsilon. Okay, so the first value will be 0, and then when you will integrate, you will get epsilon square divided by 2, and this is epsilon. And when you will put the limit -1 to x, you will get x square divided by 2 plus x, and the lower limit minus 1 by 2 minus 1. So overall will be x square divided by 2 plus x and plus 1 by 2. Vikram, are you getting this? So you can easily see that there are all the terms are positive. That means this PDF will be increasing. This PDF will be increasing. Okay, this PDF will be increasing. So how we will make the graph? Similarly, you can calculate for case 3 as well. Okay, similarly, you can calculate for case 3. You can take the case 3 when the x is lying between 0 to 1. Okay, x is lying between 0 to 1. Then this is fx of x. It is minus infinity to x, p of epsilon, d epsilon. You will break the limit minus infinity to -1. It was 0. Okay, plus -1 to 0. It is x plus 1. Okay, and from 0 to x, it is minus x plus 1 dx. So it is nothing but a x square by 2 plus x, limit is from -1 to 0, and plus minus x square divided by 2 plus x, limit is from 0 to x. You can write epsilon for change of variable. You can write it as epsilon also. And when you will solve, you will get lower limit minus 1 by 2 plus 1, minus 1 square minus 1 by 2. Here it is minus 1 by 2. When you will put the lower limit minus 1 by 2, and plus here you will get minus x square by 2 plus x. So overall you are going to get minus x square by 2 plus x, and minus 1 has become plus, so plus 1 by 2. You are going to get this one. So minus x square by 2 plus x. So here you are seeing that the x is coming negative. So that means when you start increasing the value of x, now the value will decrease. Now the value will decrease. Epsilon is the dummy variable. Epsilon is a dummy variable. Okay. Now it will start from -1. It is going like this because it is continuously increasing and increasing like this. If it goes like this, then what will happen? Okay, as you can see that it is increasing. At x equal to 0, it is 1 by 2, and it is 1, and here at x equal to 1, it is reaching to 1, and after that it will be 1 and 1. It will be 1 constant in 1. Got it, Manas, Vikram? Is there your doubt clear now? Now the plot only you have to do, and I hope that you have understood the plot because I have made the plot also. Hello, hello. Okay, guys, thank you for watching this session. We will meet tomorrow with the tomorrow, not tomorrow, on Monday with another topic of the communication, where we will discuss another concept of uh, digital communication. Now we will take one concept of digital communication. Correct?